Thank you for joining this lesson. Kindly subscribe to Shifting Grades as we continue studying. We're going to do physics today, and we're going to look at work, power, energy, and machines. So we are given a question which says that an electric crane lifts a load of 2,000 kilograms through a vertical height or vertical distance of 3 meters in 6 seconds. Determine, Roman 1, the work done. Therefore, we have some work here which is being done, through a vertical height. So, for us to get work which is done by raising a given mass or a body through a vertical height, then we do what we call gravitational potential energy. So, gravitational potential energy is usually given by the mass times gravitational pull multiplied by height, such that in this case we shall take the mass of 2,000 and we multiply it with gravitational pull, which is 10, then we multiply by the vertical height, which is 3, such that we are going to get 60,000. Because it is work done, we get in joules. These joules, which are beyond 1,000, can be expressed in terms of 1,000. Instead of 60,000, then we can say 60 kilojoules, like that. Another question is asking us to determine the power developed by the crane. We know that power is the rate of doing work. So for us to get power, we can get the work done and we divide with the time taken to do that work. Now that we are doing 60 joules of work in 6 seconds, then the work done is going to be 10,000 joules per second. So joules per second is a unit called watts. So we can say 10 kilowatts. So 10 kilowatts is the power which is developed by this machine, which is a crane. Then we have a part 3 which says the efficiency of the crane if it is operated by an electric motor rated 12.5 kilowatts. 12.5 kilowatts. So what we should understand is that the efficiency of a given machine is given by, the efficiency of a machine is calculated by power output out of power input multiplied by 100%. So efficiency is expressed as a percentage, and this is going to be the work output is the work the machine is able to do, the power it is able to give. So the power developed, then the power it is operating at is what we call power input, which is 12.5 multiplied by 100, and this gives us 80%. So the efficiency of this crane is 80%. Apart from that part, we are given another question here which says that there is a bob of mass 20 grams suspended using a string 4 meters long from a support and swung through a vertical height of 0.9 as shown in the figure 9 below. So this figure is showing a bob which is swinging 0.9 meters vertically. Then we are told to determine the potential energy of the bob at its position shown. So at this position, whereby it has risen 0.9 meters, then the potential energy, just as we've done in the other question, is going to be mass times gravitational pull multiplied by the height through which the body has gone. And this is going to be a body of 20 grams. So a body of 20 grams, we're going to change the grams to SI units so that we may use 20 out of 1,000 to make them kilograms, multiplied by G, which is 10, and a vertical height of 0.9. 0.9. So we can check the energy developed, the potential energy used so that the body might attain that height. So the height, the energy is going to be 0.18 joules. So the potential energy is 0.18 joules. After that, we are told to determine the speed of the bob when passing through the lowest point during the swing. So during the swing, this body is going to drop again in the reverse direction now, so that it may swing until a lowest position. So it is going to swing until a lowest position, then raise again to a new position, such that there is a moment the bob is going to be at the lowest position. There is a velocity it is going to possess, and it is what we're going to calculate now. It is very important to notice that energy is never lost nor created. It is only converted from one form to another. That is the law of energy conservation. So what we should know is that the potential energy it has at the highest point is going to be converted to kinetic energy at the lowest point. So all the potential energy is going to become kinetic energy at the lowest point. And this is where we say that potential energy possessed at the highest point, at the lowest point, it becomes kinetic energy. And we know the formula to get potential energy is mass times gravitational pull multiplied by the height, which is equal to kinetic energy, which is given by half mass times velocity squared. Such that now, because in this equation, mass is appearing in both sides and it is mass of the same body, it's an equal value and can cancel out, so that we may say G, which is 10, times 0.9 should be equal to half times V squared. To remain with V, we can multiply through by 2, such that we multiply this side by 2, and 20 multiplied by 0.9 becomes 18. So 18 equals to V squared. And to get V, which is our velocity, now we ought to get the square root of 18, which is going to be 4.243 meters per second, because this is velocity. So thank you for following. Kindly subscribe to Shifting Grades and share this link.